Victron Energy battery monitor, and a battery monitor basically has a shunt, which is this piece down here, which goes in the negative side of the connection, and it just measures the amount of amps going through it. So it tells you your battery voltage and the current that it's consuming or being put back in. So why did I go with this? With my Victron Energy solar charger, it gives me the battery voltage, but it's not tracking it over time. Right now I do have a battery monitor. I have a Renogy monitor, which is right here. So as you can see, I have amps, I have volts, I have current, I have it in watts, I have the estimated time before I run out of battery. So get some alarms, I guess, and stuff, and I also want to be able to read the data from my helm station. So I put that fridge in. As you can see, it just kicked in, good timing, and now it's drawing 61 watts. It's pulling out 1.17 amps, and my battery voltage is now 50.9. So I should really measure that so I have a better answer, but the fridge kicks in maybe once an hour, once every 45 minutes probably once every 45 minutes, and it kicks in for 5 minutes maybe. I'll show you the draw of the fridge. It's maybe 65 watts when it first kicks in, and then it sort of drops down. You saw it settling down. Right now it's I'm drawing 47 watts with my lights. My what else have I got going? I guess I've got just the lights going. It doesn't include the solar panel. So the solar panel, if there's sun out, it's producing voltage. So then I actually have plus, and the shunt reads it as energy being put back into the battery, because I put the negative side of the solar panel as well on this side. So it's forced to go through the shunt backwards. So why Victron Energy? I've been impressed actually with their stuff. Originally I was going to go Renogy, but that one doesn't have any Bluetooth. This one has Bluetooth built in. So right now when I run my Victron app on my phone, I can get my solar charger, I can get the inverter, and now I'm going to be able to get my battery monitor, so I'll be able to watch the battery as I'm at my helm station. So now that I know and fully understand the battery performance and how to check if it's charged, even with the specific gravity of all the cells, I'm confident in the battery, but I need to know where it is, so that way I could kind of estimate am I really fully charged or not. So I wanted to put this Victron Energy battery monitor in place to replace the Renogy, because I wanted the Bluetooth. Essentially, that's the primary reason. The secondary reason is that I understand that I should be able to get some history from this product. So I should be able to see the battery statistics a little bit more over time to be able to determine the condition of the batteries, and that's what I think I get out of the app. At least I'm hoping. Aside, the number one reason is just I want to be anywhere on the boat and know what my batteries are. So the Bluetooth, it's perfect. It's built in. I don't need one of those dongles. And then there's also one other thing that's kind of interesting. The Victron Energy has started working with Raymarine, so my Axiom, what's it called? My Axiom chart plotter also has a Victron Energy icon, and it can read data. So there's a cable that converts to the NEMA 2000, however you pronounce it, and you can take this data and then get it in my chart plotter. So I might be able to put like a dashboard and see my condition of my batteries at any time in there, and then I believe I can set up alarms in the Raymarine to start alarming me if my batteries are too low as well. So I can get alarms out of here, I can get alarms out of there. It's just better. I get alarms out of my Renogy, but I just don't have a history. I don't have web access or Bluetooth access, that sort of thing. So this is the unboxing. This is the 712 version. BMV-712. They also sell a BMV-702. This was about 300 Canadian. It was 280 bucks Canadian. So I don't know what that is in American. Divide by 1.3 right now, I think. So a couple $100 American. And I just got it at the dealer there because they've been very helpful over at Ontario Battery with helping me understand my battery situation, because I didn't quite understand that originally. But I'm doing a little better now. So what's inside? Actually, the first thing I wanted to say is I just love the fact they put the wiring diagram in the back of the box. It's not that complicated a wiring diagram, but if you were like a little bit not sensitive, what's the word? Gun shy about doing this kind of thing. You know, just I know this company is impressing me. They spend time thinking about how people use their products, which is important. So I get a cable to go from the shunt to the monitor. I get the actual battery monitor. So I drill a hole. Okay, oh, that's pretty simple setup. I just take this back ring off and then just screw it back on. So drill a hole, slip it in, and that's essentially the battery monitor. So not too complicated. The back side looks like some inputs. So this is for this cable here, the black. They've got the VE Direct, and that's what you would go, this little white cable or white connector. There's a translation cable I can get for a couple $100, but it'll let me get onto the SmartNet for Raymarine. And I don't know what those are there. COM, NO, and NC. So I'm going to guess that there may be some triggers or something. I don't know what that is for. Common ground, so NO, NC, I don't know. Serial number, part number, and I guess if I have a hole that's a square, I can put that over it too. Which is kind of cool. I'm glad that it's got a, what do you call it, a faceplate though, that's good. So screw that on. Faceplate. This is the shunt. So the shunt looks very similar to the Renogy one. It's 500 amps, 50 millivolts is what it takes. So there's actually, this is kind of interesting because the way that this thing works with the battery load, there's a BMV-1 and BMV-2. So you actually need to feed it voltage, and I didn't quite understand that, but this little circuit board, it gets voltage, and I believe that's how it powers the display, is through this cable. So you need to give it power to power the display, because that's basically how it works. So this side is the load and charger, and it's pretty big, 500 amp shunt. Basically, here are the things that can break out if you put more than 500 amps through it. You got a little fuse line. This goes into some power source. They give you a second one for the other battery if you've got two batteries, and they give you, that's interesting, another little serial number sticker if I want to stick that into my my parts list. I've got a list growing over there of stuff I've bought, and some screws to screw it in. So that's kind of the bulk of the products. And then they give you another huge, massive manual. I don't know how many languages this is in. Oh, here's the quick manning guide. That's actually all I used last time too for the inverter was and the solar controller, was just the quick guides. So battery monitor, shunt. They give you a wiring diagram, how to connect up your batteries, etc. So looks pretty cool. Oh, that's interesting. Midpoint voltages are not identical, is what it says. So it can't tell me the exact voltage of every battery, is what it was saying there. Okay, well anyways, that's the product. I'm going to install it and then do maybe a little follow-up video at the end of just how it functions, and maybe give a demonstration of the Bluetooth app. But that's basically what you get. So you get a quick guide, you get a manual. It looks like it works for up to 48 volts. I'll confirm that later. and you got the battery monitor itself, and there's a few little displays, but essentially it's almost the way that I would, once you get it set up, you don't really go and click on it too much. If you want the history and things, or the app for Bluetooth, you access it on your phone. And they give you a fairly long UTP cable. It's still in setup mode, so I don't know how to get it out of that. Oh, there we go, setup. One battery. So it's taking out 21 amps. It's 1,000 watts. So in my 10 kilowatt motor, it's only using 10% of it. And it's saying that I can run for 5 hours based on this speed, which might not be right. I have to think about that for a bit. And then putting it forward. Just wait till my boat gets to the dock here. Okay. So I have about the same. That would be where I would run it normally. So I'm running at 20 amps. So I guess the good news is that my prop thrust is in around about where the battery draw is under normal conditions. When I was running it hard, this is how I was running it. You know, I'm drawing 50 amps, and you can see the time remaining is just going down. But I don't normally run it there. I run it about here. I'm just going by the sound. So I normally run it around 20 amps or 1,000 watts, so 1 kilowatt. So I've got lots there. So yeah, much better design in my opinion, hands down. Just the ability to be able to mount something. And then this one here, you need to put a wrench on both sides. That's a screw-in post, so it was simpler for undoing. I didn't need 2 wrenches. So yeah, that looks like